We can keep discussing. Ooh! Hello everyone, let's do today. Oh wait, hold on. It's September 24th. Let's do it today. Oh my god. It's a tough question. What is it about? Sum of prefix scores of strings. Well, we're doing try today, so I'm 95% sure that it's probably something about try. By the way, I need to really switch to C++ when I solve this.
Oh yeah.
But it takes time because I need to do I need to include C++ in my NeoVim, and I need to spend some time reading the like I have no idea. Like if you ask me to create an array, I mean, okay, I know like the primitive array I can do, but if you actually know, I probably need to read the documentation again to see how, because C++ is slightly different from Java when you create an array. No, what I'm saying is all the STD, right, all the library array, right, all those, I actually don't know. And then, you create something using new, and you have to release the memory at the end. You have to call delete at the end. Yeah, so it's not that straightforward. So let's just stick with Java for now, and then maybe this weekend I can put this as a task for this weekend. Man, I want to do something else this weekend. I have a feature request for my library for the scroll indicator.
I'm also gonna deal with the pictures.
Oh yeah, we deal with the pictures, but I'm okay. So we deal with the pictures, and I will deal with the C++ because the other one requires more time and a more dedicated investment. And I have a feature request. I need to do this feature request. It's a good one. I will not do exactly how that guy asked me to do, but I will expose something. Like I will expose an API so they can do it on their own. Shouldn't be too hard. I don't think it will be too hard, but we'll see. Anything related to animation, yeah, you really don't know. Things can get very tricky. All right, what we have an array of words of size n, consisting of non-empty strings. Define score of a string word as the number of strings words I. Wait, hold on. The score of a string word as the number of strings words I such that word is a prefix. So the number of words I such that word is a prefix of words I. For example, if words is this, then the score of AB is the number of strings inside this array such that this word is a prefix of. So we have 2. Yes. Return an array answer of size n, where answer I is the sum of scores of every non-empty prefix of words I. String is considered a. So basically, ABC. Return an array answer of size n, where answer I is the sum of scores. Sum of scores of every non-empty prefix of words I. So we'll say the score of A, of AB, and of ABC. And for A is 1, 2. Of AB is 3, 4. Of ABC is 5. Okay, hold on. I think I finally understand what this problem is trying to do. ABC, AB, BC, and B. All right, so what we want is, given ABC, I have 3 prefixes, which is A, AB, and ABC. So I want to find the score of A. which is 2, score of AB, which is 2, score of ABC, which is 1. So this gives us 5, right? AB, I already calculate. A is 2, so AB will be 2 plus 2, 4, exactly. BC, we haven't calculated B yet, so we have to do B. B is 1, 2, and BC is 1, so this one gives us 3. And B will calculate B is 2, so it'll be 5, 4, 3, 2. 5, 4, 3, 2. Okay? A, B, C, D, basically A, B, ABC, ABCD. Okay, so we are going to do, apparently, something of, I think I'm going to use a map for this, so I can do, like, this is a string, and I can do string matching. Yeah. Okay, but definitely we'll build a trie. Right, so we'll build a trie to do this. So we have, A. Actually, that's not how we want to do the trie. So let's say this is a row node, and then we have A, and then we have a B, right? And an A, and we have a B. That's it. Go A to B, and then from B to C, right? And then we have, this is AB is a word, ABC is a word. For B, we have something, and then we have C, right? So that's a trie. So after we build this, now we start for every single one, right? So we will count for ABC, we do A, right? We need to count how many words start from A, basically, right? So we go to A, but we don't know how many starts with A. You don't know. So we don't know how many ticks are there. So we need to put a counter. All right, when you build a trie, we need to put a counter. So basically we hit A once, so we count 1. We hit A second time, so this will be 2. This will be 2. And this will be 1. ABC will be 1. Actually, we probably don't even need the end. So it'll be 2, 2, 1. And this will be 2, and this will be 1. Okay? So we do A. We go to this node. We find 2. So A is 2, right? And then we do AB. So we go down. B. So we're at plus 2. And then we do C. So plus 1. Right? AB, ABC will be 1. And as we go through this, we'll also populate this this memo, right? This memo thing. So we get 2, 2, 1. That's for this. So this one, A, we already done. AB, we're already done. Ooh, we have to call substring so many times. Damn, I wonder if there is a better way to handle the substring matching thing. All right, we only have 1,000, so I think it should be fine. Yeah, I think this is actually not a hard problem. This is, of course, you have to know about, trie. If you don't know about trie, I can see how this can be hard. But if you know about trie, especially after the past two days, right? Everything is about trie, so it's very natural that you're gonna do tries. But the trie will be a little bit different, right? What we're gonna do is we will say here int count and map character trie node. Oh yeah, the most complex about C++ is class and overloading. I mean, so far what I see, they have private, they have a modifier for the actual variable. They're private, protected, and public. And then you have overloading all the functions and operators. And you have left value and a right value. Yeah, all those. And passing by value, passing by reference, and passing by pointer, and dereferencing. Yeah, these are hard. Yeah, it's not gonna be trouble for sure. Oh, and you know, I don't know if you remember, we have the default constructor, and we have move constructor, copy constructor. Yeah, these are the hard thing. It'll be hard if you want to build everything from start, but I mean, in my case, I don't think I need to build everything from start. All right, anyway, so let's do this first. So for string w of words, right? Yeah, this is just like we can even call this template. These are like a template. And then for char c of w dot to char array, right? So what do is we say node dot children dot put if absent c new try node, and node equals node dot children dot get c, and you need to say node dot count plus plus. Okay, so now we're done. Next we're gonna do a map of string and integer memo hash map, right? And then we're gonna say and arrest new int words dot length. Okay, for int I 0i smaller than words dot length I plus plus. Okay, try node equal to root. And then for int j equal to 0j smaller than words I dot length j plus plus. So this is, we're gonna use substrings, and then string sub equal to words j dot substring 0 to j plus 1. Okay, so this is my substring. And if memo dot contains key sub, right? If not, if it doesn't contain, then we do this. So we put this one here, right? Then we do so we say the current one it doesn't contain. So we can basically say if at the beginning it doesn't contain, yeah, whenever it doesn't contain, so we will just go through the path. Okay, I'm trying to see if we need to really do this every single time. So I have current sub. If it contains, I just do it. If it doesn't contain the current sub, I'll go through the thing. Right, I'll go through my timeout though. If you think about it, my timeout, because you're calling substring every single time, right? So I'm trying to see if there is a better way. Yeah, I think we should do substring every single time. I know we have to do two. Holy crap. We need to do two tries. One try is to set up, right? One try is to set up the score, and the second try is, yeah, then what you need to do is just go through every single one. And if it's not, yeah. Holy moly. Wait, hold a second. Didn't this one already done? We already have the score, right? We do one try, we already have the score. So we just need to traverse this try. We just need to traverse the trie. Let me think again. We traverse the trie. We do A, we do AB, right? We do A, B, C. Yeah, we traverse the trie, we keep the score, we add them together, then we get the result. And then the new one comes, we do A, B. Yeah, we have to go through them anyway. So, yeah, we already have it. We already have it. I don't think we even need a memo. I think all we need is we get the I, because we need to put in there, and we get the J. We don't even need to get a J. We can just go one by one and we just add it into it. So here's what I say. I say for char C of woods I dot to char array, right? And well, we do need a trie node, right? And then what we say, okay? What we say is node equals node.children dot get C and res I plus equal to node.count, right? Then we get to the next one, we get to the next one, we get the next one. Then at the end, we'll return. All right, let's see if this will work. Because you have to go through them anyway, right? So if you need to go through them anyway, what's the point of getting a memo? Yeah, there's no point. So this is purely a trie. Purely a solution purely based on trie. Build a trie from words and keep count the number of times, right? Number of times each trie node is encountered. Then traverse the trie again as we go through the words list again. Add up all the counts. Well, we call it nk, right? Right, where n is the length of words and k is the length of the average, is the average length, is the average, oh my god, is the average length of each word. All right, let's see if we missed any of the edge cases. What edge case are you talking about? I mean, we don't really have much edge case in this. All right, come on. There we go. Right. Maybe there's an easy way to... there is an easy way. Okay, so I don't like the runtime because it feels a little bit slow. So what I'm going to do here is, instead of doing this, we say trie node, children. All right. And then this will be new, only 26, right? Trie node, 26. There we go. And what we do is, holy crap, what is the original? We can do this. Arrays.fill, this.children. Will fill with null. Okay? And then we can say if no.children c minus a is equal to null, then we say no.children c minus a equal to new trie node. And this is not get. This is gonna be C minus A. Alright, everything is the same. And here we're gonna say C minus A. I betcha this is gonna make it a little bit faster, because the overhead of creating a map is quite dramatic. Yeah. Okay, let's see. I say shaving half. It's about it's not half, but like 200 milliseconds. Ah, that's about 40%, right? 40% saving just because we do this. Now, maybe there is a way to even get it faster. I think, I don't know. I like how it looks like. Let's just take a look at the solution. Right, we do try. How do they do try? Ah, we do the same thing. Oh, it defaults to no. Huh. Interesting, it defaults to no. Which means I may be able to do a little. So we say if I start with 0, okay, equals new try no 26, and we delete all this, right? So it's very simple. Yep. Wait, hold a second. Do you think this can make it even faster? A little bit more. A little bit more. Well, if this, I don't think it will pass. Yeah, I think I'll get TLE. Yeah, this is pretty straightforward, right? It's very straightforward. All right, let's go train. Let's go train. Should be good. The training should be good. All right, I'll see you guys tomorrow.